What's going on, everybody? This tutorial is going to help you if you want to figure out how to do a percent change on your Pandas data frame. If you want to skip ahead in the tutorial to a particular part of percent change that you're having trouble with, see the description for the index of the video, and you'll find it there. So basically, say we have a data frame. Oh, or before that, let's import pandas as PD, and then we'll import numpy as np, and I'm just going to copy and paste a data frame that I made in here. It's 10 columns wide by 50 columns or 50 rows long, and we'll just shrink this down with df.head, and there we go, nice and neat. So basically, if you just want to find percent change going downward along your rows, you could do df.percent underscore change, open and close parentheses, and then we're going to get nans for this first row. I'll explain why in a second, don't let that confuse you. But now we're getting decimal values right here, and these are just percent changes. If you multiply them by 100, you're going to get the percent change. And all that this is saying is from 0.99 to 0.69, that's about a 30% decrease. So it puts in negative 0.30 or 30% in proportional terms for this entry on the data frame. And it puts it right here in A1. And this just means from the last period, this is the change. So I want to talk a little bit about what is going on inside of this parentheses space, because there are a bunch of default arguments in there that I'm actually not calling, and this is very simple. But the first one that I want to talk about is periods. So periods is set default equal to 1. It's going to give me the exact same thing, but say I want to calculate the change from here, A2. I want to say how much has it changed from A0. So this is a big change right here. This is about a 96% change. So we'll say periods equals 2. And there we go. Pandas did it. And it did it for every single one of these. And now we have 2 rows of nans. So it did it for every single one of these, but the reason why it puts nans up there is because it doesn't have anything to compare it to in a past period. There's no period -1 for it to look at. So Pandas just says, I don't have enough information, and it says not a number. And it's going to do this all the way up to the end. You could check it with your own data set. It should work out the same way. Now the next thing that you might be wondering about, and we'll set periods back equal to 1. Say I don't want to go down along rows. I want to go across columns. I want to calculate percent change from 0.99 to 0.47. Then you could just use axis equals 1. And now it's going to give us 51% decrease, so 99 to 47, yeah, about 51%, or exactly. And then 40% increase from here to here. So that looks right. 47 to 67, about a 40% increase. Because the default argument here is axis equals 0. And anytime you have axis equal to 0, it's talking about the index, or the indices. And anytime you have axis equal to 1, we're talking about the columns. And you can change the periods as much as you want. I could do periods equals 2. I could do periods equals 6, or just as long as it's not too big, or it'll go off the data frame and we'll get an error. Like if I do 10 here, then, oh, actually I don't get an error. Let's try 11. Yeah, it just gives me not a number for everything, so it actually doesn't come across with an error, but that's basically meaningless data. If I do periods equals 0, then it's going to just give me nothing. It's nonsense. Or -1. If I do -1, then it gives me percent change in a reverse way. You can experiment with that if you want to. I won't here because it's probably not something that you'll be working with. Just know that you can do it if you want to. So the next thing that I want to talk about is something called fill method. And, oh, I forgot my underscore. Fill underscore method. This is another one of the parameters of this function. We'll put a little comma here. And this is set default to equal pad. Now, doing this, oh, and we'll change back to x equals 0. It doesn't look like anything has changed in this data frame. This is because fill method is designed to handle not a number values in your original data frame. And you might say there's a bunch of not a numbers here, but remember this is the data frame that we're making. This is the data frame that we're working from, df regular. And I'll just remind you what this looks like. Oh, wrong one. So the regular df, we get this output of no not a number values. So there's nothing to handle. So fill method equals pad isn't going to change anything here. But let's insert some not a number values into our data frame. And we'll say, how about df of a, referring to the column, and then we'll say 3 or 4 equals np.nan. This is why we imported numpy here at the beginning. And then we'll change it for a couple of these too. df.head. And let's say of 5 also equals np.nan. Okay, so head of, let's say 6. Okay, so here we have 2 not a number values in our data frame. This is missing data. You might have this in some of your data sets because there might not be financial data or stock data or, I don't know, ice cream sales data for whatever you're looking at. So basically, there's an explanation of this in the documentation. The pad method fills the values forward, and the backfill method fills the values backward. That explanation confused me, though, so I actually just went in and experimented in Pandas to see what these were doing. So if we do fill method equals pad, then looking back one period, we're not getting another, or we are getting a percent change value for the very next observation here. So this is percent change from 0.38 to 0.36, and that's about a negative 4% change, or a 4% change downward. So we can infer from this that pad is looking back behind the nans to fill in this data point here. Whereas if we use backfill, then we're getting 0.0 for this value. And nothing else changes. I'll just show you. We'll do dot head of 10, we'll say. And then we'll copy and paste this code up ahead, and we'll change the method to pad. I just want to demonstrate something here. So 1, 2, and 3 looking the same, but 6 is the only different one. 7 and on, they change. So this is changing how it looks back past nan values. So that, I think, is a better explanation than they give on the website, because I thought when I first looked at it that backfill meant that it looked back behind those values, but it's actually just the opposite. Pad would look back however many periods it takes to get the percent change that it needs from a last meaningful point. Backfill you might want to use if you do want missing values to mess up your data set, and then you would say if there's a 0 in the column, then do something else. And now the last argument, or actually there's 2 more, is limit. Now we'll get back our default arguments here. And let me just make this a little bit bigger. Okay. Periods equals 1. And limit. Its default set equal to none. And what it says on the Pandas website is that the number of consecutive not a number of values to fill before stopping. if we find a limit, if we find one nan, then we stop filling them in. And then the last one that I want to talk about is one that actually involves date time as an index. So I just copied and pasted this code from the Pandas website, and I'll try to link to it in the description. But if we make a new data frame that has a lot of time series indices in it, we could do a percent change by time period. So all that you do for this is TS, this is my time series, and series data frame, it doesn't really make a difference. Actually, this one is a data frame, but I could do percent change dot percent change, and I do frequency equal to hour. And just like before, it does it with periods equal to 1. I wouldn't even need this, and I would get the same result, actually. But maybe for some reason you have an inconsistent data set that's giving you every 15 minutes or something like that. And sometimes it doesn't give you 15 minutes, sometimes it gives you 10 minutes. Well, you want to do it on the hour. This way you could do it like this. And this is useful for things like Quantopian, probably, or any kind of live feed of hourly data that you would want to put in. So this is 4 hours. I could do days, and I'm going to put the link to that in the description also. But this gives it to me, once it has 1 day's worth of data, then it gives me the percent change from the last day. So date time is really a talk for another tutorial. But I hope you learned from this. Let me know if it was detailed enough for you, or if I explained everything all right in the description. And yeah, hoping to do more of these tutorials, because I know it can be really confusing when you first get into Pandas, and nobody explains all of the little parts of the function, so I'm just trying to go back and help people who are in that position now. Thanks!